In this video, we present you our tool that leverages information technology for the building industry. We show how algorithm research and graph databases can consolidate scientific data, aiding decision makers in choosing innovative regenerative design strategies. Our decision support system targets diverse groups, among them, and in particular, building developers, architects, designers, scientists, and policymakers. It provides an interactive online interface, offering a strategy for successful learning and consultation in regenerative building design. We aim to create a globally accessible, holistic, and scientifically founded tool to support actors involved in the design and planning of regenerative structures and drive the future of green architecture through intelligent, informed, data-driven decision-making. Our tool has the potential to revolutionize sustainable building design by leveraging data-driven insights, optimizing time and budget, and reducing environmental impact of building development. The underlying data of our tool can be represented in a total of 8 layers.
Tool users can choose which of building consumption flows they would like to make more regenerative and sustainable. How does energy like solar energy or hydropower, building materials like concrete or glass, products like electronics, natural resources like metals, or information translate to ecosystem services? This layer links building consumption flows to ecosystem services. Ecosystem services include cultural services like cultural identity, recreation or health, provisioning services like food, raw material or solar energy, and regulation and maintenance services like the regulation of water quality or temperature. We generally extract ecosystem services from natural ecosystems. Our tool helps users to select from a list of 56+ ecosystem services to then find out how the desired ecosystem services can also be generated on buildings. First, the user can view in which climatic context and bioregions the desired ecosystem services have already been successfully generated on buildings. Then, the tool presents mechanical, hybrid, and nature-based design strategies, concepts, and technologies that have been proven to generate the selected ecosystem services. Examples are water catchment systems, solar panels, aquaponic systems, vertical greenery systems or composting, agroforestry, and soil filtration. Users can choose from a list of more than 120 relevant sustainable design strategies for buildings. To show where building designs already have been implemented, users can view 100+ real-world building examples from all over the world. For example, Te Cura Ware in New Zealand, the Perkins School in the USA, and the Calgerzo in Spain. Our tool also connects to building norms and standards that can be achieved when implementing sustainable designs that generate ecosystem services. Apart from non-mandatory building certificates like BREEAM, Living Building Challenge or LEED, local, national, and international laws, rules, and key performance indicators are included. To measure the benefits of implemented building designs, our tool also provides relevant quantification indicators for ecosystem services generation. For example, recreational services can be measured by identifying the number or area of landscape features with stated recreational value. Energy provision can be quantified by monitoring the produced solar or wind energy. Crop yield and the presence of water reservoirs are indicators for food and fresh water provision, while vegetation cover and evaporation rate indicates temperature regulation. For building developers, it is critical to know which designs can be bought as products on the market, which is why our tool also creates that link wherever possible. There are existing companies that sell and install vertical greenery systems, water filtration systems, solar systems, or smart roofs, for instance, and many more design strategies.
All the 8 layers with relevant databases for sustainable decision-making in the building industry are presented in an interactive interface, which streamlines scientific information into practical guidelines. Data are systematically organized for both beginners and experts in regenerative and sustainable building design. This is how the nexus of different databases currently looks like for users. Different elements light up when hovering over them, showing their connections with other layers and data. However, we aim to create a new and more user-friendly interface for all types of users, like building developers, designers, architects, as well as scientists and policymakers. This is one example where users can easily choose to view relevant and interlinked databases from a drop-down menu. Data that are visualized where possible, for example, to show where relevant, sustainable buildings are located in climate zones. Our tool's information interface is constantly updated with new scientific data. It creates new links between regenerative building design and ecosystem services, serving as an inspirational platform for scientists and practitioners. Therefore, to revolutionize sustainable decision-making in the building industry, our Nexus tool provides scientifically based information as a user-friendly guide to generate ecosystem services on buildings. It contains 120 plus sustainable design strategies and products to select from to effectively guide building professionals for informed decisions. We want to make our tool easily accessible to potential users. Therefore, we are looking for an attractive and comprehensive name for our tool. Do you have a great idea? Then write your ideal name in the chat or contact us via email.